Good morning, everyone, and thank you for joining us for today's webinar. My name is Georgie Gould, and I am part of the Community Care Smart Assistive Technology team and the project coordinator at Global Community Resourcing. I will be co-moderating today's webinar with the Community Care Smart Assistive Technology Collaborative Chair, Anne Livingston. Today's webinar is focusing on the journey to assistive sleep technology. Before we begin, I would like to acknowledge the traditional owners and their custodianship of the lands on which we meet. We pay our respects to their ancestors and descendants who continue cultural and spiritual connections to country. We recognise their valuable contribution to Australian and global society. Before we start, allow me to go over a few housekeeping points. Today's webinar is being recorded and we have muted all microphones. We encourage participation throughout the webinar and ask all questions and comments be posted in the Q&A panel. If you experience any technical issues during today's presentation, please let our team know using the chat function. Our webinar is facilitated by Global Community Resourcing for the Community Care Smart Assistive Technology Collaborative. Global Community Resourcing focuses on community care and services that are innovative, customer-focused, and creates connections both Australia-wide and globally. At Global Community Resourcing, we have been fortunate to work on a wide range of local, national, and international projects with researchers from across the globe. The purpose of the Community Care Smart Assistive Technology Collaborative is to promote use, raise awareness, encourage collaboration and co-design, gain understanding of and identify barriers to the uptake of smart assistive technology in the service provision and service delivery. Our webinars are based on feedback and requests that we receive through the collaborative, and we aim to connect diverse perspectives in research and development, as well as the creation and deployment of assistive technology in the community care sector. Just a reminder, if you haven't formally registered yet at a collaborative site, it is accessible to all and free to register. A range of resources, news articles, and collaboration opportunities are uploaded regularly to the platform, and you can visit www.satcommunity.com.au to become a member today. Please note that Global Community Resourcing and the Community Care Smart Assistive Technology Collaborative is not promoting or endorsing any particular product, research entity, or organisation. The purpose of our webinars is to serve and to inform viewers of various smart assistive technology currently in development and deployment. In today's webinar, our guest speakers will explore the research and development journey of nighttime monitoring technology. Cameron is the CEO of SleepType and a non-executive director for 40 Winks. For more than a decade, Cameron has travelled the world searching for innovation and technology in the space of sleep science and research. The basis for the search was to determine what is next for the sleep industry and how the bedroom would evolve as part of the connected home. This led Cameron to create SleepType, a health tech company designed to innovate in the space of health and sleep. Professor Bhaskaran is a multi-award-winning electronic engineer and innovator. Her fundamental research breakthroughs have been recognised with the numerous awards she has won. She co-leads the Functional Material and Microsystem Research Group at RMIT University, which she established in 2010. Her work on electronic skin and wearable sensors has been patented, and her group now works collaboratively with multiple industries and design partners to commercialise the technology for healthcare and aged care. She is a migrant Australian and has a passionate advocate for diversity and is on the board of directors for Women in STEM Australia and the advisory board for STEM Sisters. Welcome, Cameron and Professor, to the Community Care Smart Assistive Technology Collaborative. Please take it away.
Thank you, Georgie. Really appreciate that. And thank you to Anne as well for having us along today. Just to set the scene for you, I met Madhu a number of years ago, I should say Professor Madhu Bhaskaran, and we have built this program side by side. And today's journey, I think when I first spoke to Georgie about what we were going to present, it was very much how did we take a research breakthrough in a lab by Professor Bhaskaran and her team and bring it into an aged care and assistive technology setting. So aged care, disability care, anywhere where you require additional support through the course of a night. So today's the journey of how we took a breakthrough to a full working prototype and on the journey to commercialize this technology. I would normally acknowledge the traditional owners of the land, but seeing as I have such a wonderful co-presenter today, I will not steal her thunder, and we will sneak across and get straight into our presentation right now. So that should be the right screen you can see there, the journey to Remy, and the details of both myself and Madhu up on screen now. This is a collaboration that we built this together, and as such, I think you probably need to hear from the person who started the journey in the lab a long time ago, and I'll hand over now to Professor Madhu Bhaskaran.
Thank you, Cam, and thank you, Georgie, and thank you, Anne. Thank you for inviting us to present our story together. I'll like to start by acknowledging the country. So we acknowledge the people of the Woiwurrung and the Boonwurrung language groups of the Eastern Kulin nations on whose unceded lands we conduct our business. Sleep Titan RMIT University respectfully acknowledge the ancestors and elders past and present. RMIT also acknowledges traditional custodians and the ancestors of the lands and water across Australia where we conduct our business. Next slide. Thank you, Cam. So before we launch into our story, I was going to take you a little bit along a research story. I'm hoping it won't get too technical, but the reason behind expressing this part of the story is trying to give you a glimpse of what the challenges are like in the research world. What motivates us? How do we get started before we, then reach out to industry and start partnering with them to commercialize our technology? So for those of you who are not very aware, if you have the unlucky thing of breaking your smartphone or your smart device and you look inside, you will see quite a few silicon chips. Now, those silicon chips are made in a lab which looks like the lab on your left-hand side of the screen. They are what are called clean rooms. They are called clean rooms because they're extremely clean. You're flushing that lab out of all the particles which might be there. And the reason behind you doing this is every particle which might be present in that lab has the potential to destroy hundreds or thousands of devices. Really, really tiny devices made at the micro or the nano scale. So every hair particle which might land on it, skin, oil from the skin, all of it has the potential to destroy millions of devices. So when we go into labs like these, we don what are called clean room gowns or bunny suits. So you can see a photo of me on the right wearing a bunny suit. It's quite unconventional because as opposed to wearing lab coats where you're protecting yourself from the lab, this is where the bunny suit is essentially protecting the lab from you. You are the contaminant. You are the person who's going to potentially destroy millions of devices because of all the particles or the hair or the skin we bring in. And so we're trying to make sure that doesn't happen and our hard work doesn't go down the drain. So these labs are available all over the world. Obviously, all our electronic devices are made in labs like these, but the picture you see here is the lab at RMIT University, where a lot of these technological breakthroughs kind of have their beginning. Cam, next slide, please. So that's pretty much a smart devices which you see today. And hopefully you don't have this bad an experience where pretty much you drop your phone or it falls down or something like that happens and the screen cracks or doesn't quite work as it used to work before. The other problem with these smart devices is they're so sophisticated and so miniaturized. It's not a do-it-yourself repair. So it's not easy for you to go and figure out, what I need to replace. How do I make sure that it starts working again? Usually the solution is get a new device. So these are the kind of problems all the smart devices have. And one starts wondering, we're constantly progressing, we're constantly miniaturizing, we're constantly adding functionality to it, but these kind of problems never seem to quite go away. Next slide, please, Cam. Maybe this is what we really want. At least that's my vision. I'm not sure how many people share the same vision, but this was pretty much the vision with which we started the project back in 2012. We thought, what if technology could be unbreakable, foldable, conformal, and stretchable? Surely that will solve the problems in terms of, having it break all the time or fail on you most of the time. If you can have technology like this, which is pretty much on a contact lens type material, then we probably would not have some of the issues which we have in terms of it breaking or not quite working well. So that was kind of our motivation. How do we take current technology as it stands and render it unbreakable? Next slide, please, Cam. So if you Google the word wearable sensors, these are kind of the images which kind of come up. So it's not just me who had this utopic vision. It's quite a few researchers around the world. And all of us are trying to see how we can bring technology closer to ourselves and bring technology on our skin or close to us, but making sure at the same time that we overcome some of the challenges in getting there. So any of those technologies which are there, which are monitoring the environment around you, or they are monitoring, changes within you. And for that, they typically need to be a wearable sensor. What are the typical challenges you need to overcome? Now, I was talking to you about silicon chips. Now we can no longer go with silicon chips, which is quite hard and brittle and inflexible if you're trying to use it as a wearable. So you want something which is soft, a bit like a contact lens type material, which is a polymeric material like rubber, on which the entire electronic device is built on. Now, typically every electronic device will use what are called metals. So metals are conductive layers which help them form the electrical connections. So it's not just the device which needs to be stretchable. You also need these conductive layers to be stretchable and be willing to, be conformal to your skin. You also have functional layers, so metals don't do all the job for you. So for you to have a wearable sensor, you need some kind of a functional layer on top of it, which does the sensing for you. So typically, again, in this case, use what are called metal oxides. And again, those metal oxides need to be stretchable and functional. So you can create an entire wearable sensor, which incorporates a substrate, your conductive layers, and your functional layers. So that's pretty much a challenge which we have. How do you marry off these very, very different materials to create your wearable sensor of the future? Next slide, please, Cam. So that was a challenge which we had back in 2012, and it took us around 3 years to come together and create solutions in this particular space. Now, this is very, very fundamental research. It essentially brings together materials engineers, electronics engineers, people with the science background like physics and chemistry, and we try and bring together all our knowledge to create those research innovations. Next slide, please, Cam. So that was pretty much the challenge. You have really, really brittle materials on one side, a bit like glass. So even though I call it metal oxides are essentially glass-like materials. Glass, for instance, is silicon dioxide. So imagine combining something like glass with a contact lens type material and trying to create a wearable sensor. That was pretty much the challenge we had in front of us. They're very, very different. They're mechanically very different. They're thermally very different. And they're also very different when it comes to actually processing them or manufacturing them. But if you can manage to overcome this challenge, you really, really open up a big plethora of applications, because pretty much any sensing can be done as long as you incorporate the right kind of metal oxide layer. And that was a challenge which we had, which we overcame over a period of 3 years. A lot of eureka moments, a lot of mistakes, which then lead to, innovations. But it was a fascinating journey just going down that particular path. Next slide, please, Cam. So that was what we had. If I was doing this face-to-face, now would be the time I usually send a sample around. So because when people actually interact with the technology, they instantly understand what I'm talking about. Using words like contact lens material, glass material, it kind of helps you envision things. But I think the minute you touch this, you instantly understand the challenges which we had and what we managed to create. But I'm hoping these images, which can speak 1,000 words, will help you, get that message across. But that's pretty much what we had. And in 2015, 2016 was when we patented this technology. We had the ability to make sensors on a conformal platform, which could stretch, which don't break, which are transparent in nature, and could be modified for any kind of end application. Next slide, please, Cam. And then it started a new journey for us. We thought, okay, we are engineers. We love to create solutions to problems. We love to not have this technology sitting within the lab. How can we actually make sure this technology leaves the lab in partnership with industry? How do we get it out into the real world? The problem, or the nice thing, depending on how you look at it, is we have what's called a platform technology. We just didn't know which direction to run in. Everyone told us our technology is really, really interesting. They could envision a million ways in which could be used, but we didn't really have people who could really go, all right, here's a little bit of money which will help you take that technology in a particular direction. And I think we were looking for that particular direction. We spoke to over 40 or 50 different industry partners and trying to understand which particular direction to run in. Do we use this to monitor the world around us, monitor UV around us, and try to give us UV sensors which you can wear on the skin? Do you want to monitor things like pollution? Or do you want to monitor your own body, like, measure your skin temperature, your ECG, your blood oxygen levels, and things like that? Those were the kind of projects which we had in mind, but we weren't quite sure in which particular direction to go in. Things changed for us dramatically, especially in the last 3 years. One of the first projects which we had was with CAM, and that's the smart bedding products for aged care monitoring and support, which we'll be talking about in terms of a journey today. But we also started working with other industry partners in terms of doing health monitoring or aged care health and infection intervention, or again with the UV sensing, trying to wear patches on your skin, which might give you an alert in terms of you've reached your UV limit for the day, you need to go in and put on more sunscreen. Next slide, please, Cam. I'll just touch on one wearable, which I think is pretty interesting for the audience of this particular presentation. And these are wearables which we make, which you can put on your skin. So a bit like the image on the left, that's a Band-Aid sized wearable or a postage stamp sized wearable, which you can place on your skin. Now, this wearable is wireless, as you can clearly see. It either communicates through NFC technology, which is pretty much how your credit card can be used, or your phone can be used for PayPass. Or you can use it as a Bluetooth technology, where it's basically collecting all the information and sending it to the cloud to store it. This particular patch, which the person's wearing on the skin, that has the ability to monitor the person's skin temperature. We're also working on it to measure the blood oxygen levels of the person and also measure the ECG of a person. So imagine someone in a residential aged care facility or an older person whose body parameters need to be monitored quite regularly. They wear something like this. This allows you to have that information of them without having to constantly keep hooking them up to wires and keep gathering that piece of information of them. Next slide, please, Cam. And this is also one of the things which we developed in that particular project, which is basically a wireless wearable ECG sensor. Now, this is quite a breakthrough because a typical ECG monitoring is done like the image on the left. And that's the most accurate way to actually monitor your ECG data. So you have around 10 electrodes attached onto you, and you get that information, which you then process and try to understand what's wrong with the person's heart and is everything okay. We have managed to miniaturize that same system into what you see on the right. So a little patch, with just 3 electrodes, which you attach onto your skin, and you get that information of it in terms of waveforms, which you can get onto your phone. We're still in the process of characterizing a lot of this, but this is basically my example to show you the promise of this technology, where you can go wireless and you can also have these being worn on your skin, and thereby enable you to get a lot more data about yourself without having to keep checking yourself into medical institutions to gather that level of data. At this point, I'll hand back over to Cam to start telling the story about Remy.
Thank you, Madhu. And I hope that gives everybody a really good insight into a base technology and something that I came across. So when it was still that stretchable piece of device, that was when I was introduced to Madhu. But at the same time as Madhu was on her journey, I was on another journey within my family business, and that was an attempt to future-proof, at the time, the 40 Winks business. So off the top, Georgie was telling you that I'm a non-executive director of 40 Winks. My father was one of the founding members of that group, and I still sit on that board today and still have a shareholding and an interest in that business. But what Georgie probably didn't mention off the top, and that's probably because I never told her, is that when my family first came to Australia, my Oma, you can probably tell by my surname, I've come from a Dutch heritage, and my father was born in the Netherlands. But when my Oma first came to Australia, she ran private aged care homes in Melbourne. She ran a number of them through the 1960s, 70s, and even up into the 1980s when my father went into 40 Winks. So my background as a family and family heritage had been in and around the bedroom, as well as in and around a care setting. So there was all these ideas going on in the back of my head. One thing I did note, and this is where the idea really, really started to take shape, was that the quality of care through the course of a night in a residential aged care facility, in my opinion, from what I'd seen, was not where I believed it should be, and not with the access to the technology we have now. Now, I spent a lot of time traveling around talking to CEOs and COOs and clinicians within residential aged care facilities, but I also spent a lot of time working with carers and walking the floors with carers, not just registered nurses, but your workforce, your care workforce, an invaluable workforce that is overworked at all the time, and particularly through the course of a night. Now, the standard of around Australia at the time through a night was the hourly rounds where you do a door check, or in some facilities, it was a pressure mat that would, when a resident stepped on it to go to the bathroom, would trigger an alert for the carers that there might be an issue there. Sounds great, but the reality, when I spoke to the carers and when I spoke to residents within aged care facilities, they were so many false positives or breakages that in many cases they didn't use them. In some cases, I heard stories of residents shuffling to the end of the bed to get away from the pressure mat. They didn't want to trigger it. And the words I would often hear is, I don't want to be a guinea pig. I don't want to be poked and prodded. I just want to go about my life. So in my mind, I'm sitting there going, okay, how can we create a system that is non-intrusive? So the resident doesn't feel like, or the consumer, depending on the language you use, doesn't feel like they're being monitored all forms of the night. But for the carers, we can give them some form of safety net that can't be broken, can't be gotten around, can't be anything done to it, but just be a passive thing in the room that provided some support to that care workforce. So I went about building a team to create a product, create a solution. In this picture here, Madhu and myself, and we were introduced through the Australian Academy of Science back in, I think, 2017, roughly, when we were taken out to lunch. And the Australian Academy of Science had a wonderful industry advisor who brought us together over a lunch. And I saw Madhu's breakthrough. And at that stage, she didn't have an industry partner to take it to market. She was looking at UV, as you just mentioned, and some other environmental factors. I looked at it and said, I don't want to do a wearable. I want to do a nearable. I want to take it off the skin, off the body. I don't want the person to have to interact with it. I want to put it onto the surface of a bed. And Madhu, being the brilliant researcher she is, and as she often says, she's flexible with her senses and she's flexible with her approach. And she was willing to come on the journey with me. And I started to build the collaboration team. On either side in that picture of Madhu are her co-leads at RMIT, Sharath Sriram, over her left shoulder, right of screen, and the newly minted professor, Samit Walia. All three of them are now professors. They were all associate professors or doctors when I first met them. But this shows you the respect that the university has, and all three of them are now professors. And on the right is a very important person in this collaboration, and that's Bill Mancis from a company called Sleep Easy Bedding Australia. They're one of the top 5 biggest mattress manufacturers in Australia. They make internationally components for the bedding market. They sell machines to the European market, spring units to the North American market. And it was critical that we brought a finished product manufacturer to the table for this research from the outset. This is something that starts to threaten the model of the manufacturers. And to be able to have one of them see the opportunity and come with us on the journey was incredible. But that was our original collaboration team. And that photo was taken back in 2018. I'm a bit older and grayer since then. And that's from the development work that's going on. But why aged care? I get asked this a lot. We could go into neonatal care. We could have gone deep into hospitals and healthcare. We could have gone into defense, high performance. Why are we so focused on aged care? Well, I hope you understand that there's a bit of interest from me from a family perspective. But it's also, we have a tsunami coming at us. And everybody that's here watching this right now knows this. You know it because you've been talking about it to your friends and family. We've seen it coming. And the fear we all have is that the number of people aged 85 and over in Australia is projected to increase from 2% to 3.7. So that is some crazy numbers of people being fired into a sector that is already under stress, particularly in residential aged care facilities. We can't build facilities quick enough. And in regional and remote communities, we just don't have the infrastructure, the scale or the size to be able to put them out there. So we have to create technologies. We have to create systems that allow people to age in place. Aging in place is a key focus of ours. So we're not just focused on the residential aged care facility, although we are building a product for that, but we're also allowing or building programs and products to be able to keep people in their home for longer. So here is Remy. Remy is a project that we started in 2018, and I should say a big thank you to the Australian federal government, who through a cooperative research centres project grant, they gave us $1.7 million out of a total project of about $5.5 million worth of investment to take that breakthrough technology Madhu talked about into a system of sensors that are embedded into mattress protectors. So in a residential aged care facility, we use the exact same material on all beds in one of those facilities, and we print sensors directly onto it. Now, when you look at the bed, what does that do? Well, you can't tell any difference. It looks identical to every other bed in every other aged care facility all around the country. Has the same level of infection control. It has the same level of waterproofness. It has the same ability to be cleaned with all the usual standard disinfectants and detergents that are required to be used in a residential aged care facility and even in a hospital setting. So we built the system to live within the current parameters that are used and the current structures and systems and processes that are used in a facility. And what it does, though, is through a control box, which is one additional piece. So there's one additional wire that comes out through the top of the bed, very low voltage, extremely low current, because this is printed through ink, is the sensors, which we can go into more detail at another time. But essentially, we then send a signal from that bed as to the presence. So whether it's a person in bed or not a heavy object, because if it's a heavy object and they're trying to fool the system, it will actually trigger an alert that we have a concern that that person has not moved at all in a certain period of time. What posture they're in. So are they in the prone position, the supine position, the fetal position on their side? How are they sleeping in the bed? There's some very interesting information that can be generated and useful for us to know what posture they're in and also what position on the bed they're in, which is critical when we start to build the program for fall prevention as data starts to come through. So on that screen, you'll see a dashboard. That's more of a research-based dashboard than the consumer-facing one. But what it's able to show you is the various quadrants on the bed where the sensors are located and the movements there within it. But we are tracking this real time through the course of a night. To give you a bit of an idea, now this has no audio, so I'll just talk over the top of this video. Our aim is to be able to, through the use of macro data over time, prevent falls, intervene before falls, start to intervene before pressure wounds start to occur. We're monitoring pressure over time. So if someone hasn't moved, at the moment you're using variable air chamber mattresses, we could drive a system that only puts that pressure through, or the various air chambers rotating air through on the skin when necessary, not on a time module. So as you can see, the bed looks identical to that which is currently used in a residential aged care facility and in many home care settings. The little box that was there to the side of it is the comms box. That has very minimal amount of computing power. The bulk of the work is actually done up in the cloud. So there is a lot of data we're extracting at all times. I mentioned before that the Australian federal government supported us. That was critical because that got us from that breakthrough and helped fund all the way through to what's called a technology readiness level of a 6, which is a fully functioning and working prototype. So moving along to how REMI works. At first, we were going to build it into a mattress. And then we realized because of the price conscious nature of the aged care market, I shouldn't say price conscious, price sensitive. There is really no surplus cash to be throwing at very expensive technologies. We needed to build it in a very low cost environment. And that was probably one of the biggest challenges that Madhu and her team went through, is that all of the usual go-to materials that they would have liked to have used didn't fit within the pricing matrix that we had developed and determined by studying and learning and working directly with the aged care sector. So instead of building an entire mattress, which would mean you'd have to retrofit a facility to be able to take advantage of REMI, we built the cover only. So you can actually just buy the covers for your facility and keep the same foam core because it wraps around all Australian standard sizes, and we can scale up or down on size based on the printing techniques we've done. Now, we've actually patented the process of this as well, and we've just lodged our PCT, which is our global patent as part of the patent treaty, which allows us to claim global exclusive rights, or I guess the global patent on our designs and manufacturing processes, not just on the system of data extraction, but how to manufacture this. That was where Sleep Easy was so critical. Now, that was what we started with. And we were at the micro nano scale when we started with Madhu and her team. And one of the big challenges, I'm sure Madhu will be able to talk to it if you've got any specific questions about it, was taking it from this micro nano, very small structure, and then blowing it up, making it bigger so it would fit across the entire surface of a mattress. Many of the devices you'd see internationally in these beds are actually quite rigid electronics, as Madhu mentioned at the beginning, brittle, inflexible, and they have to go under the mattress. The benefit of this breakthrough has meant that we can put the sensors right up at the top of the mattress, right near the skin. Now, you would have seen in the video before that it had respiratory rates and heart rates. We've already proven in the lab that we are able to extract respiratory data off REMI. And we've also, through that same signal, because it is so sensitive, we have in the lab again also been able to prove that we can extract heart rate data through that. Now, we're not switching that on in the aged care sector at the moment. That requires a lot more testing, measurement, and learning before we start moving to what would essentially be a Class 2A medical device. But we are working to a 13485 compliant quality management system on our pathway to be a Class 2A device. But it was a really interesting journey for us, and the critical element of this and how we differentiate from the vast majority of technologies that are out there in the marketplace globally is that we are very keen and focused on being a nearable. One of the biggest weaknesses of the wearable market, if you speak to anyone, I'm sure you all understand it if you've been interacting with them now, is that you have to rely on someone to remember to put it on, someone to wear it, someone to have to interact with a wearable device, whether it's a carer that has to remember to attach that Band-Aid type structure that Madhu showed earlier, or help someone put a t-shirt on. This is very hard to do in certain levels of dementia care, in certain levels of or various areas where you can't rely on the quality of care time and time and time again. You have a transient workforce, you have people that come in as casuals. Very hard to get it repeated night after night after night. And when you're playing with data, when you're playing with research, it needs to be replicable. It needs to happen every single night. And the big thing for us was making sure that it was passive in the room and being a nearable. Now, Madhu, I know you might want to jump in and have a bit of a chat here. This the world map resized by population, something that I know you've ended up talking, you've started your world in the research sector, but you've ended up talking to quite a few aged care conferences yourself. Did you want to talk about some of the things that you've learned in your journey as well as you've been developing REMI?
Sure. Thank you, Cam. So it's interesting. And I know it's been fascinating in the last 3 years when we started our collaboration. So like Cam said, we were introduced to each other in 2017. And we decided to talk about this and then put a grant that will help us, support our entire work together. The grant didn't get up the first time, but then we reworked it. We resubmitted the grant proposal. It's a very different world, bringing the world of industry over to grant proposals. I think there was a lot of education which had to happen in terms of Cam learning about grants. How do you apply for grants? How do you manage to squeeze your entire life story into those tiny 200-word boxes which they give you to type about, what's your motivation and how are you going to do this? But like Cam said, we wouldn't be here if we didn't have the support through that CRCP grant, which we got awarded. But so since 2018, when we started this entire journey together, I've been fortunate to be invited to quite a few aged care technology forums. It's funny because Cam's been invited to probably the same number of, forums which happen within universities where they're asking Cam, how did you come and start working with academia? What are the differences in these cross-sector collaborations? What are the challenges and how do you work together? So when I go and do these aged care forums, some of these were in fact held in other countries. So for instance, I was doing one in Singapore. And I remember presenting this technology very early on at that stage. At that stage, we didn't have a product to show off. We only had an idea, and we had an idea of how to actually get there. The question I got asked in Singapore was, this is very, very complicated. Why don't you just put a camera inside the room and then you'll have all the information which you need to ever have? And I said, oh my God, I can't even raise this as a potential solution in the Australian market or in a European market. And I guess that's where we really, really understood that even though aging is a worldwide problem, it's not unique to Australia. Everyone all over the world is aging. We all want to age productively. We all want to age well. There are cultural differences in the way the entire aged care is being approached. One solution which works for one particular market is not necessarily going to work everywhere else. For instance, I come from India, where people assume that if you put your parent in a residential aged care facility, it's equivalent to abandoning them. So I can't even broach this entire topic over there. And whereas Cam will touch on this, later on in the presentation, but there's no reason why REMI is limited within the four walls of an aged care home. It could be brought into a home to facilitate in-home care. Imagine your loved ones just sleeping better at night, knowing very well that their mom or their dad has REMI under them and is able to, keep track of their position, posture, or presence of them in the bed. And then, being the usual advocate for diversity in STEM, I also started wondering about the gender differences. Are there differences in the way, men or women or other genders, how do they lie in bed? Will the product which we develop be sensitive enough to pick up these differences? Because I don't know how much you've been reading about technology being created for people in the world, but it's pretty much a male-dominated, technology which we have around us. Most women are invisible in terms of, the way technology has been created. So having that constantly in front of the mind, making sure that whatever we create is going to work for no matter what culture we're trying to deploy it for, what gender we're trying to deploy it for, was quite important for me. Manufacturability, that's a challenge we can talk about for years, for many, many days. But like Cam said, having Sleep Easy on that partnership was absolutely critical to where we are standing right now in terms of our success. I showed you the initial photos of where I developed my technology. We were, bunny suits. We're inside clean rooms, extremely clean environments. How do you take the technology from a lab like that and take it out into a manufacturing sector and have it, fabricated where you're really worried about how clean is this room and how is this technology going to work? How do we go from those tiny, tiny micro nano devices into a macro scale mattress sensor arrangement? Those were the kind of challenges which we had. And like Cam said, reliability was really, really key for our product. We certainly didn't want to create a product which keeps giving you false alarms and then people instantly lose their trust in the product. But obviously, the price point is very sensitive as well. We use a lot of gold and platinum in a lot of the sensors which we make within the labs, not because we love those metals, but because of the fact that they are really, really, they're not environmentally, they're not sensitive. So unlike using silver or aluminum, which tend to, get oxidized, we tend to use more of gold and platinum because they're biocompatible and they, last longer. That's out of question. There's no way I'm going to be able to incorporate gold and platinum within this kind of a product, but that doesn't mean you need to lose out on the performance, right? So having those kind of conversations early in the piece was something which was key. The other thing which was also important was we could have easily made a prototype device within our clean room labs and then gone and scratched our head and wondered about, now, how do we take this and make it into a manufacturing ready product? We didn't do that. We had nearly 2 years of challenges where we were literally just trying to make the prototype in a manufacturing facility. Our entire aim was we thought if we can make the prototype in a manufacturing facility, upscaling is very, very easy. And then we can hit the road running when it comes to, field trials and then taking it out to commercialization. It was a very different approach to most of the products which we make, where we make prototypes in the lab and then worry about upscaling. This was literally where we decided to make the prototype in the manufacturing sector. And then, we didn't have to worry so much about upscaling. The final point over there was user interactions. And I think like Cam said, and like I touched on earlier, there was always that entire focus on making sure the end user was kept in mind. We certainly didn't want to create a product which is going to be difficult to use, which the nurses are going to find a big hindrance and therefore, avoid using it, or which is going to add significantly to their workload. So making sure we keep how they operate during the course of the night and how we can ease their load and make it easier for them to offer the right amount of care at the right place at the right time was something which we were keeping in front of our mind all through the journey. Next slide, please, Cam. So that's what we created on the one on the left. So the one on the left, which you see, is the entire process by which we could go from making sensors on a contact lens type material, but actually elevate that entire process to creating now sensors which can be integrated onto a fabric. So how do you have the stretchable conformal sensors, which are now mass printed, screen printed across an entire sheet, which can then be easily adhered onto fabric? So we worked closely with CPC, so you can see some of the equipment on the right over there, which is manufacturing equipment. How do you create that entire flow on thing where we can have a roll-to-roll processing of creating sensors which go onto a fabric? That was an entire journey which took around 2 years' time. Now, we could no longer do the very sensitive process we do in the clean room. We use very sophisticated mask aligners, a process called photolithography, where we are patterning by light. We moved and pivoted quite significantly into moving into a screen printing type technology. So similar to the way t-shirts are made and you get your entire patterns onto t-shirts, can we use similar technology to actually create our sensors and thereby integrate them onto fabric? Those were some of the changes which we had to make as we pivoted towards a manufacturing friendly product. Next slide, please, Sam. Cam might touch on this, but one of the things which has come through us all through the entire project, and this is very, very close to Cam's heart. I think when Cam first broached this topic, it was more about, the focus was more on sleep. How do you get a better night's sleep? It was not so much about aging initially, but it was more about everyone sleeps. We spend, I think, 1/3 of our life sleeping. but we do have very little data about the way we sleep. The qualitative analysis of our sleep is very, very minimal. So one of the exciting things which happened as a result of us creating REMI was, the launch of a sleep diagnosis evaluation trial with Flinders University. So this was something which we launched earlier this year, and we'll go into, I think, a start of next year or the end of this year, where we start using REMI not just for the residential aged care homes, but can we actually use REMI to understand the quality of our sleep overnight in a much better manner. One thing which always stands to me is if you see the way sleep diagnosis is done with a lot of things hooked up onto you and wires hanging off you, it's not the most natural way to sleep, which means that the evaluation which is done as a result of that need not be the most accurate evaluation. You're not sleeping in the normal way you sleep, which means the evaluation has a lot of error associated with it. One thing which most people tell us whenever they interact with REMI is we just can't feel the sensor. It's unfeelable. Where's the sensor? Are you sure there's a sensor over here? Including at the launch, we had a lot of people interacting with the technology, and it was fabulous to see that kind of feedback. So hopefully REMI is a much more natural environment to conduct the sleep diagnosis trial. Next slide, please, Cam. I'll hand back to Cam to take over the rest of the journey of REMI, but not before I say a big thank you to all the contributors. We lead a very large group. We work quite closely with industry, and it's been fascinating to do these multi-sector collaborations. But a lot of people in this photo have had touch points with REMI along the process. Like Cam said, REMI is very close to my heart because it was our very first industry collaboration, a big collaboration. And so having that ability to have students involved in the process, getting their insights, as you can see, it's a very gender diverse and culturally diverse team. So having all those people contribute to the innovation which REMI has brought forward today has been really, really special. Thanks, Cam. On to you.
Thank you, Madhu. And I should also mention, Georgie, since we sent you the biography of Madhu, she's now been appointed, I think, co-chair of Women in STEM Australia. So well done, Madhu. She is certainly a rock star in the world of research. So where the true power of REMI is going to be in the data and the data extraction. We've been talking to companies all over the world that are very keen for us to not only provide them big data insights over big groups of people sleeping through the course of a night, but what we can do with a machine learning overlay on this, and whether it is developing algorithms that predict falls or predict susceptibility to pressure wounds, or one we're working on as well is being able to identify residents or people that might need additional audit because they're lying in the bed every night. We know that rapid weight loss in the aging or the elderly is a key sign of health decrease and that we need to intervene. In order to start sharpening the focus and making sure less people slip through the cracks when it comes to auditing, this is where we're looking at the additional bits of pieces of data we can provide to caregivers, whether it's family or whether it's more formally with a care or nursing service or even with doctors in the future. The key is getting good quality, reliable data. On that sleep evaluation trial, Madhu was mentioning before, we're working on seeing if we can pick up nocturnal seizures. So things like restless leg syndrome, or even in the case of epilepsy, if there's a nocturnal seizure, one of the leading causes of death in unexplained death through the course of a night is a thing called SUDEP, sudden unexplained death in epilepsy. So we're working on lots of features that can be added to this, and it all comes from that big data. And again, user interaction and making it very easy to understand has been a key focus. So over the last 3 odd years, whilst Madhu's been working in the lab with the manufacturers, we've been doing a lot of focus groups with carers, with nurses, with the CEOs, because again, there's data we can provide up to the key decision makers who might have 40, 50, 60 facilities, and they don't have the ability to have the touch point on the floor in all of those. So we can give them some insights for benchmarking across multiple places that they manage all over the country. From prototype to product is the big piece of our focus right now. And one of the most amazing things that's happened over the course of this year, since we launched REMI as a fully functioning prototype with the then Minister for Industry, Minister Karen Andrews, who came and helped us launch this product back in March, is that the Advanced Manufacturing Growth Centre has now supported us with a commercialisation grant, which will be the next evolution that we're currently working in. RMIT have also provided us space in their city campus where we've moved from our showroom and facility spread between Hawthorne, where our showroom is in Melbourne, and Campbellfield, where traditionally our test facility was. We now have a full lab and test facility on site at RMIT on the other side of a corridor from the Functional Materials and Microsystems lab. We've been there for a month now, and our lab is being built, and that's a huge thanks to the Australian federal government that have increased their support by another roughly $900,000 over the next 18 months to help us take it from a prototype to a product. We've already had one unit in the field, and it's been in the field since October, and it's responding very, very well. And Friday next week, I'm not going to jump the gun and announce it just here, but Friday next week, we're making a big announcement as to a national field trial program that will be occurring throughout the course of next year. This is a program that is both residential aged care facilities as well as home care or an aging in place model. So we are developing both products in parallel because we know that's what the market requires. The idea here is set and forget though. The big benefit of this, again, down the track, where we're going is we know the sector that's most in need of this technology right now is aged care. That is why we are focusing, and we are going to deliver on that project over the course of the next 12 months. But the opportunities are huge in this space, and Madhu alluded to it before with the additional information. I just mentioned epilepsy and sleep evaluation. So we, with respiration and other bits and pieces, we can also take in environmental. And in fact, we've built our ecosystem to take in noise, light, temperature, and other sensor information that we are going to put together with Flinders and RMIT and put it up against a polysomnography machine, which is the industry standard, the gold standard for sleep diagnostics. So what we are going to do is see whether our 6 or 7 data points extraction and program and data set can be as reliable as a polysomnography. And that will allow us to do full sleep diagnosis in the home, which is a huge leap forward in the place of sleep science. We've had significant interest out of the Defence Force. Boarding schools being able to determine whether the children are in bed. There's risk at night there as well. We've had a lot of interest out of transport workers, so truck drivers, pilots, making sure they're well rested, making sure they've had their sleep and they're meeting their requirements. We've had a lot of interest out of prisons. In fact, one of the first people that contacted me was a prison out of Queensland that are wanting to make sure that the well-being of their prisoners is actually being monitored, and the risk mitigation piece is how do they determine they're all okay through the course of each night. Neonatal, we're getting respiration, we're working on heart rate, we get position posture. Remember, if you've had anything to do with SIDS, and I lost 2 cousins to SIDS, so in my family, Red Nose Day has been a very big thing, and SIDS prevention is something that's in the back of my mind from the day I started developing the REMI program. And it wouldn't be a shock for you guys to know that we actually have done the vast majority of our lab testing on cot mattresses. So there are huge future applications there as well. We've taken up a massive amount of your time, and I really wanted to thank you all for sitting through that presentation. I saw one question that did pop up there in the chat, and just to reiterate, yes, we are required to meet TGA standards. We've been getting regulatory advice from the very beginning from one of the world leaders when it comes to pathways and making sure you've got compliance with the various regulatory bodies, whether it's the FDA in the USA, the European EMA, or even with the TGA in Australia. We are working to all international standards and all Australian standards. We are working to a 13485 compliant quality management system, and all of our software is also being developed with that in mind. The big discussion right now is the first version, is it a class 1 or do we go all in on a class 2A at the end of this program? But we have decided we're building it as though it's a class 2A so that we know at any stage we can switch on that functionality. It's a massive challenge. It's a huge cost impediment within this process as well, but we're in this for the long term, as I'm sure you saw. And Madhu talked about her breakthroughs being platform. Well, I hope you can see from this presentation, it was quite lengthy in the end, that REMI is also a platform technology. And where that goes, we essentially ask anyone out there in the care community to come and interact with us because we want to learn and we want to add functionality that is what you require. So thank you very much for listening to that discussion.
Thank you very much, Cameron and Madhu. What a comprehensive discussion. I'm going to take over from Georgie now. So those of you who don't know me, Anna Livingston, the chair of the Community Care Smart Assistive Technology Collaborative. I've seen many unusual faces and names on the participants list today. So have you got any idea, Cameron and Madhu, when you might be market ready?
Yeah, we are on track to be market ready at, I would assume it's Q3 of the next financial year. So we're talking early 2023 is when we'll be on track with a TRL 9 based on our current timelines.
Fantastic. Look, I've got a number of questions that have come in through the collaborative. Obviously, the application you've talked about in residential aged care, but the majority, as you are aware, of individuals live in their own home. How have you thought through the monitoring process of home-based deployment?
Just trying to unmute myself there. Thank you, Anne. One of the key elements of that is making sure, and over the development of the next 12 months, we're working on that product. We've been talking to home care providers about what they require, but it most likely, where it is working to at the moment, will be an app-based program, or so essentially where the loved one could purchase and then use the monitoring for themselves. But we have been talking to over the journey people like Bolton Clark and other home care providers, or nurse on the move style providers, about integrating with their systems. In fact, we've had a couple of meetings with some companies out of South Australia, as we've noticed security companies that do the rounds in their vehicles are now starting to pivot into responding in an aged care environment down the track. So I guess this is one of the areas where we're spending a lot more time interacting with the sector and learning as we develop it. Where we've been over the last 3 years is building the stability of the platform. The system of sensors in the cover can fit in any market. And from a manufacturing standpoint, the same base would be delivered to a home care environment as it is into a residential aged care facility. But what we're working on at the moment is more focus groups with the various care providers, as well as people from Dementia Australia. It was a big one, actually. I had a really interesting meeting with them because people that have those suffering with dementia in the home, they're actually interested in knowing not over 10 minutes out of bed, but can they get immediate alerts when they're out of bed for wandering? So there's various elements we're still learning, and to be totally honest with you, but it will most likely be app-based and in the hands of the consumer, being the loved one.
Thanks, Cameron. One of the issues that comes up regularly in our collaborative is about the ethical considerations of assistive technology, particularly those that aren't wearable, aren't voluntary, aren't applied necessarily by the person. This is a big issue across the sector with vulnerable clients, and particularly clients with reduced capacity, perhaps as you mentioned, those living with dementia. Has this been a feature or a discussion within the use of your platform?
Yeah, because we would be extracting a lot of biometric data, we do need to, and have been building all of our systems based on the various requirements of medical devices when it comes to software and data extraction. We've built in place systems where we anonymize the data so that if anyone interacted or breached, which we build our system so there wouldn't be any breaches within it, they wouldn't get anything other than squiggly lines and ones and zeros, and wouldn't know it was an individual's data and other bits and pieces. We also, through the field trial and then moving into clinical trials, are required to provide ethics. So I've got a director of research and development who joined our team in November. And his focus is very much on data security, and also making sure that we follow all process protocols to require that basically the individual is supported. But it is a very key consideration. I mean, you're starting to play around with people's personal data, and you're getting long, 18 months, 12, 24 months potentially of insights that are great and advantageous when you're helping to diagnose or to look after and deliver better quality care. But at the same time, there is a very serious other side of it if there is a breach in their personal data. But we have from the very outset been building towards all international standards in software as well as the manufacturing hardware.
Terrific, thank you. In terms of the capture of that data, we know in aged and community care settings, we collect a lot of data, but we rarely use that data. Georgie and I recently led a piece of work for the Australian Aged Care Industry Technology Council for the Department of Health, where we looked at where the sector was positioned for the uptake of more innovative approaches. One of the areas that was concerning, and we know that the Minister picked this up, was the collection of data in relationship to quality indicators, the mandated fields of reporting that residential care and soon to be community care providers needs to collect and report on as part of their compliance journey. We found that only slightly over 40% were over 40% were still collecting those manually. And that's obviously a concern to everyone when we've got technologies that are very effective and efficient and perhaps better than the hands and the heart in collecting and recording and certainly analysing data. Have you explored the impact that this development can have in assisting providers? I think you intimated you have, but like a question.
Yeah, I can give you some more meat around the bones of that, and absolutely, you are spot on. I've seen some of the best, and I've seen some of the worst out there on my journeys, and you know, we've all read, or we should have all read the final report into the aged care, the Royal Commission to Aged Care Quality and Standards, and it's pretty scary what's been going out in some places. In fact, I even had one place, I'll never ever name names, but I had one facility many years ago ask me if we could turn off functionality if they didn't like what they saw there. But I'm sure that won't be a shock to people that are in and around the sector. I've begun by not wanting to build an ecosystem that you have to buy the sleep tight ecosystem in order to take advantage of the ecosystem. That's not how we operate, and that's not what we want it to be. So I've already been in contact with people like Health Metrics with their eCase program to provide data through to them so that we can plug in and give resident management or patient management software companies further data. One of the things that came to me from some of the best CEOs I met in the sector, they said, take workload off our carers. We need them doing the job that they want to do, and that is caring for people. We need to take the manual processes off them. So from the very beginning, Anne, and it's a really good question, we've been looking at how do we make sure that there's not another layer to the workflow. In fact, if anything we do, we should be taking their hands off it, or taking the workload off them. And that's the manual tasks of the data entry and the other bits and pieces, which is why we have built our system to be agnostic of resident or patient management software, meaning we can plug into any of them. What we do with that data, again, I see us as having three users, essentially. There is the resident, the consumer, the loved one that would sleep on the bed. Now, if we're doing our job properly, they don't even know we're there. In fact, we're just the safety net piece, which is, you know, giving them peace of mind that if anything goes wrong, they're okay. Then there is the carer or the loved one in a home care environment. And they're the person that is administering the care, and they need information that relates to them, and no more and no less. And one of the big things we're going through right now is, because we're collecting so much data, what's the data we keep and what's the data we throw away, for want of a better term, each day? Because again, you know, storage of that data, if it's not useful to anyone, then it's not worth storing. But that's one of our others. And one of the ones I alluded to earlier as well is, the amount of times I've had CEOs or COOs or even board members who are, you know, they're legally responsible to what goes on in these homes around the country or facilities around the country. They want better quality of benchmarking care, and they can tell you the facilities and the areas that they've got concerns over because they don't have line of sight. So we're trying to provide them systems where we can give them data and insights that can provide benchmarking, which means from a risk mitigation point of view, from a management, from a duty of care point of view, they're able to make the best decisions with the best information. So, and I know you'd be well and truly across all of this, but I hope that gives you some sort of answer that it is well and truly in our developmental cycle.
Thanks, Cameron. I'm going to give Madhu some comments or questions here. Madhu, congratulations on your achievements with women in technology and promoting the role that women can play in the range of science and technology areas. Aged care is similarly gender biased. It's a female workplace, and most of the real work, in inverted commas, is done by women. Often the women in this area are over the age of 45, and in some cases not had the opportunity to interface with the digital world and have the levels of digital literacy that perhaps younger generations do have. But we're forcing them more and more in the aged care and community care sector to interface with technology of whatever sort, whether it's just recording their client notes in a smartphone or using assistive technology such as your development. Do you want to comment on some of that and what's going to make this technology work when we're faced with predominantly a digitally challenged workforce, where more and more, because of the workforce shortages, the interface with technology is going to be pushed upon them, not fostered or encouraged, or perhaps time spent developing up digital skills and literacy?
That's a really interesting question, and something which no one's asked me before. Put my thinking hat on, but for me, like I always keep saying for the last 2 years, this pandemic would have looked very, very different if not for technology. And I think as a migrant sitting in another country, I thank technology every single day, because I would not have been able to keep in touch with my family if technology didn't exist. I also have I have a few grandmothers who are very technology averse. And then I also have a couple of grandmothers who love and embrace technology. So I think for me, I've realized people and their love or their adversity towards technology does not come in one shape or size. There are people who adapt it at the age of 80, or, there are people, sometimes even me, who at this age literally go, I just learned how to do this yesterday. I can't go and change the entire way I'm doing it. So I think for me, that's one of the reasons we constantly kept talking to people right from the beginning, in terms of trying to understand that this doesn't significantly add to their load. One of the things which kind of comes to my mind is RMIT, and it's not a plug for RMIT. I guess most organizations would do this. They're offering what are called micro credentials. So really tiny modules which will help you, learn how to embrace this digitized world, and learn to embrace the advantages which it offers, and overcome sometimes, I guess, our mental barrier in making sure that we can embrace that. We're hoping Remy is a user-friendly product which doesn't require you to significantly update your technology skills, and thereby, almost do a crash course in trying to use the technology. And I'm hoping, as part of rolling out Remy within the residential aged care homes or within other sectors, we're also able to do that part of, where we're able to offer them that digital awareness and the ease of actually interacting with technology, where we give them a little bit of a guidance or, a little bit of training in getting there. But really fascinating question. I'm going to go and keep thinking about it more. But with Remy, I'm certainly hoping we can help them overcome that.
And Madhu, one of the in many of our projects throughout the sector, one thing that sticks out as a significant differential is the opportunity to have the staff on the front line particularly, but at all levels in an organisation, be part of the co-design process. And that not only assures that obviously the product is modified and becomes more fit for purpose, but any of those workforce issues are sort of ironed out at the development stage to ensure that product is as well refined for the skill sets of workers there. So they're great inputs. I'm very conscious that we're actually over time. I'm sure that this won't be the end of a conversation. And I know that many on the line today and those who will view this webinar after the recording's release will be in touch. This is an important development, and we're keen to follow this as your product develops. So thank you for your time today. It's been fabulous, Cameron and Madhu, to have your expertise on board. and it's been fabulous to have the opportunity to have a informal dialogue with you about your product and your journey. Our next collaborative will be on the 8th of December, tomorrow. And we're looking at goods, equipment and assistive technology, some new support systems that are available. Thanks, Georgie. So just on behalf of everyone in our collaborative, our 2,000 plus people who are really interested in the role that assistive and emerging technologies will play in a new and vital, I think, community and aged care landscape. Thank you, Madhu and Cameron, for your presentation today. Thanks for everyone attending. I'd like to call out particularly to Georgie Gould for co-chairing today and organising the workshop, the webinar in the background, and Cody, who's been our technical advisor. I think his first time on that role. So congratulations, Cody, you got through to the end. Keep in touch with us. Our email address is there. We look forward to you attending future activities. Thanks, everyone.